All right, when we're talking about extrema, or extrema, however we want to say it, we're talking about maximums and minimums of functions. And if I've got this function here, we're going to have a relative max and a relative min. And that's because the slope of my function, or the first derivative, goes from positive to 0 to negative, and from negative to 0 to positive. But wouldn't you agree that's the same function. Wouldn't you agree this function also has a relative max and a relative min, because the slope goes from positive to negative, and in between it's undefined. It's not differentiable at the cusp or corner, but that still gives us a maximum, and a slope going from negative to undefined to positive also gives us a minimum. So we're really looking for when my first derivative changes from positive to negative or negative to positive and is equal to 0 or undefined. We're talking about that slope. So those will help us find our critical numbers. So in order to find the relative extrema of my function g, we're first going to go find the slope. And g prime of x is 4x cubed plus 12x squared. That slope is never going to be undefined because we're not dividing by x. But when is it going to be equal to 0? We could factor out a 4x squared and say x plus 3 would be left. Therefore, 4x squared equals 0 when x is 0. And we also know x plus 3 is 0 when x is negative 3. So these are my two critical numbers that I'm going to plug into a sign chart. Negative 3 is smaller than 0. Those are x values. I'm going to plug into the first derivative to then find what's going on with my function. I'm going to plug in a number less than negative 3 between the two numbers and bigger than 0. Again, these are my critical numbers though, negative 3 and 0. I'm going to plug in negative 5 to my factored first derivative. This quantity is going to be positive no matter what I plug in for x. Negative 5 plus 3 would be negative. If my first derivative is negative, my function is going to be decreasing. If I plug in a negative 1 here, I'd get a positive times a positive, which is a positive. And again, if my first derivative is positive, my function is increasing. And if I plug in a 5 here, we would get another positive first derivative. Therefore, my function would be increasing. Therefore, my function is decreasing from increasing, has a slope of 0, and then increases again, so has only one relative extrema. To know when a graph is concave up or down, we're looking at the second derivative. Oh my gosh, how convenient. They gave us the second derivative. Our critical numbers, or the numbers that go on the sign chart, are when that second derivative is equal to 0 or undefined. This polynomial will never be undefined, but it will be equal to 0 when my x is 0 or when my x plus 2 squared is 0. And that would happen when my x is negative 2. So my two critical numbers are negative 2 and 0. We're going to plug those into my second derivative and see what's going on with my function. I'm going to plug in a number smaller than negative 2, between the two, and bigger. I'm going to plug that into my factored second derivative that they already gave me. This quantity over here is always going to be positive, so the fact that I'm plugging in a negative 5 means I will have a negative second derivative, meaning my function is concave down. If I plug in a negative 1, my second derivative will still be negative times a positive, which is negative, so it's still concave down. And if I plug in a 5, therefore my second derivative is positive and my function is concave up. They're curious about when my function is concave up. It will be from that critical number and to the right, so anything bigger than 0. So I'd say my answer is B. Points of inflection occur when the second derivative changes signs. And they already gave us the first derivative, so I'm going to go find that second derivative, which is 3x squared minus 4. All right, we've got to see when is that undefined or equal to 0. It's never going to be undefined, so let's go see where it equals 0. And I get x squared is 4/3. Therefore, x is going to be the square root of 4 over the square root of 3, which is 2 over root 3. Okay, that's my critical number that I'm going to plug into. I'm going to plug numbers around it into my second derivative to tell me if I've got points of inflection. I'm going to go ahead and say 0 is smaller than 2 over root 3. And if you're saying, I don't know what 2 over root 3 is, we'll just be dramatic and say I think 10 is bigger than it, because I definitely agree. If we plug in 0 to my second derivative, do you agree 0 minus 4 is negative 4, therefore my second derivative is negative and my function's concave down? If I plug in a 10 to this second derivative, I'd get a very big positive number, minus 4, which is going to stay positive. If my second derivative is positive, my function's concave up. Therefore, my function changed concavity from down to up at 2 over root 3. Answer C means my point of inflection is at 2 over root 3. All right, we're asking about minimums in this function. And again, a minimum occurs when my function has a negative to a positive slope. All right, so we need the slope. And guess what they gave us? The slope. They gave us f prime. So we need to see, when is that slope equal to 0 or undefined? So when is sine of x squared? That will never be undefined, but when is that equal to 0? Because this is calculator active, we could just use our calculator and say, when is this graph equal to 0? And when I look at this graph, it is pretty crazy, okay? This is the graph that we're dealing with. Whoa. But notice where these x values are. We obviously have infinite amount of zeros, and it's curious where we have minimum. So I'm going to change my window to start at 0, and I don't know, my biggest number is 2.5, so I'm going to change my window to 0 to 3. And I'm left with this graph, which helps me a lot. It wants to know where we have minimums. Minimums occur when my slope, or f prime, which this is a graph of f prime, goes from negative to positive. These are all positive values, negative, 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 positive. So I'm looking for this 0 right here. When I do second calc 0, I get 2.507. 78 is asking about points of inflection. Point of inflection is where my second derivative changes signs. And conveniently, they gave us the second derivative. Because it's calculator active, I'm going to go ahead and plug in my second derivative to my y1. And I'm going to go see how many zeros it has, or how many times it crosses the x-axis. This is my initial graph with my window from 0 to 3 as they told us to do. But still, I don't feel confident about knowing how many zeros. I'd say I feel confident about 1, 2, 3 here, but I don't know what's going on over here. So I'm going to go ahead and change my y window to go to about -2 to +2. I take that back. I had to change my y to -0.5 to +0.5 because I still couldn't tell if I had zeros here, and I do. 1, 2, 3, 4, 5. The answer is going to be 5 points of inflection because my second derivative is changing signs. Negative to positive, positive to negative, negative to positive, positive to negative, and negative to positive again. All right, where do we have maximums? Maximums happen when my first derivative goes from positive to negative on this interval. So I'm going to go ahead and type this into my y1, because this is my first derivative, into my calculator and let it graph it for me. Okay, here's my graph when I changed my window from -3 to 3. Then I also changed my y min to -3 to 3 so that I could see where is my first derivative going from positive to negative. That would be happening here and here. So I'm going to go ahead and do second calc 0 to find those zeros, and I get A. Okay, to know when a function is increasing, if a function is increasing at any time, it just means that the slope is positive. Again, they gave us the slope, so I'm going to go graph that. I'm going to graph what they gave me, and I'm going to go see where its values are positive. Okay, when I did zoom standard here, do you agree if this is f prime, all of these values are positive? Sure, they are decreasing, but that's not what we're asking. For a function to be increasing, the slopes have to be positive. These are all slope values. They're all above 0. So my function is always increasing. All right, they gave us the graph of y, and they want to know which graph could be the derivative. Well, my function starts with a slope pretty close to 0. Then it has a negative slope, 0 slope, positive slope, approaching 0 again. Because my slope starts around 0, my f prime would have to start around 0, which I feel good about B and A about. I don't like C because it starts already in the negatives. D starts around 0. E, I think, starts around 0. Okay, so then we said our slopes were negative and then went back to 0. These slope values are all positive, so I don't like A. Again, these slope values are positive, don't like B. D and E are still in the running. We go from a negative slope to a 0 slope to a positive slope. So I like that this was negative slopes, 0, positive slopes again, approaching 0. These are negative, positive, negative slopes again. Up here, we never go back into the negative, so it has to be D. Here's a free response question testing us on maxes and mins, etc. So they gave us the graph of f prime, and they want to know where we have a maximum. Well, again, a maximum happens when a function has a positive slope then a negative slope. Since they gave us f prime, these are slope values, and it has a positive to a negative slope at -2. So we would say my maximum is at x is -2 because my f prime graph changes from positive to negative. Done. For my function to be concave down, the second derivative has to be negative. If my function is decreasing, the first derivative has to be negative. When I go look at my graph, the first derivative is the slope. The first derivative is f prime, but look what they gave us. They gave us f prime. So where is f prime negative? Well, that is from -2 to 4. So I like the interval -2 to 4 for this part. But where would my function be concave down? Well, that's when my second derivative is negative. The second derivative is the derivative of f prime, or the slope of f prime. The slope of f prime is negative from -3 to -1 and from 1 to 3. Where is the overlap between these two? I would say we get to have overlap from -2 to -1 and from 1 to 3. Again, brackets, parentheses, it doesn't make a difference. My function is concave down. We're going to say f is concave down and decreasing on these intervals because f prime, f double prime, and f prime are negative. All right, points of inflection happen when that second derivative, when f double prime, when f double prime changes signs. Well, my second derivative is the slope of the first. So when is the slope of my first derivative changing signs? Let's get a fresh graph. My slope of f prime is changing signs from negative to positive at -1, from positive to negative at 1, and from negative to positive at 3. So I'd say we have 3 points of inflection, -1, 1, and 3. And I'd say my answer is points of inflection at x equals -1, 1, and 3 because my f double prime changes signs. Okay, if they gave us a graph of f prime, which of these graphs, A, B, C, or D, could be the original function? Well, my f prime has positive values for everything that I just highlighted. That means that it had a positive slope in the beginning of my graph. A starts with a positive slope. B does not. C does not. D does. What we notice that it still has positive slope here, but approaching 0. And what we'll notice in A is that it's got a positive slope. It approaches a slope of 0, because again, that tangent line would have a slope of 0. Then it goes negative. We had a positive slope, 0, negative. I'm like an A. Okay, on this number 80, again, calculator active, but a calculator would not help you, unfortunately. They're asking where a minimum would occur on this f prime graph. Well, minimums happen when my slope goes from negative to positive. Because this is a graph of slope, we're looking for when the slope changes from negative to positive or just goes to negative. So my function could always be like this on a closed interval, and this is my minimum. So I'd say these are negative slopes, are really approaching positive. My minimum is going to happen at 2. Okay, last question on mins and maxes. They gave us a graph of f prime, and it said we've got a vertical, my slope at 0 is vertical. Yeah, we've got a vertical tangent here. My slope, f double prime, is not differentiable here. We've got a cusp up there. Which of the following statements is true? So let's go see what we've got. It says my second f prime does not exist at 2. Wouldn't you agree f prime at 2 has some value? We don't know what it is, but it is a value. Okay? My second derivative would not exist at 2, but my first does. Is my function decreasing from 2 to 4? Well, again, this is a graph of f prime, and these are actually positive y values. So my function is actually increasing with a slope that's approaching 0. So I disagree with B. The graph of f has a point of inflection at 2. Does my second derivative go from positive to negative at 2? Yes, I'm feeling good about that. Is it differentiable there? No. But doesn't my slope go from positive to negative, so we would have a point of inflection? Yes. Do we have a point of inflection at 0? Well, my slope of f prime goes from positive to 0 to positive, so it didn't change signs. Do we have a maximum at 0? Well, when I look at when x is 0, my f primes actually went from negative to positive. If my slope goes from negative to positive, I actually have a minimum, not a maximum. So the answer is C.